Hello, I want us to study these examples together. This example is on latitude and longitude and is taken from WAEC 2003, number 11. It says an aeroplane flies due west for 3 hours from point P. So you can see the P point, which is latitude 50 degree north, longitude 60 degree west. Okay, so this is where the plane started from, and it did at a time of 3 hours. It flew to a point Q at an average speed of 600 km per hour. So with this question, we can get distance between P and Q. We can start with that first before we move on with the solution. Since we know the time it flew from P to Q is 3 hours, and we knew the speed, the average speed is 600, so we can get the distance. So let's first find the distance. So first I need a text format to do that. So first find distance PQ. Okay, so this is what we need to do first. Okay, so distance PQ will now be what? Remember your formula for speed. Speed is equal to distance. We talk of distance PQ, put it in brackets, distance PQ over time. Okay, so and speed in the question is 600. So 600 is equal to, we don't know the distance now, so distance PQ, that's what we are looking for. Distance PQ divided by time is 3 hours. Time is, okay, sorry, divided by 3. Then your final answer will now be cross multiply, which is distance PQ will now be equal to 600 times 3. So 600 times 3, so therefore distance PQ will be equal to, so this will give us 1800 kilometer. Since the speed is in kilometer, you can see it. So 600 times 6 times 3, 18 is correct. So this is the distance PQ. Now that the distance is known, we have settled one major information. Let's see what next. They say, okay, this plane at point Q now then flies due south. Okay, from Q due south, okay, it came down to south to a point Y, 500 kilometers away. See, so distance QY is given as 500. So we need to write it down. All these are things that will help us when we are doing our calculation. So distance QY is given as 500 kilometers. It's very important. Take note of that. But when you know the distance of 2 points, the solution will not be difficult, because this topic is mainly about distance. Okay, now what next? Let's see. It now says calculate correct to 3 significant figures the longitude of Q. You know, Q longitude was not given. The plane just flew from P to Q. No information about Q is given, so we don't even know the particular point. Then we need to calculate it. Then the latitude of Y. So even Y is not given. From Q, it then flew to point Y. We don't know the latitude. So these two questions, we need to get the longitude of Q and latitude of Y. Let me just demonstrate it with this three-dimensional view so that you understand it very, very well. So this is your equator. You can see this is your equator. This is your prime meridian. So two of them give you your reference point, 0 degrees. Okay, so this plane started from where? Let's see. It started from point P, and what is the latitude? 50 degree north, 60 degree west. Okay, so 50 degree north, all I need to do now you need a point here, and that point is called point P. Name it point P. Point is called point P. Okay, from this point P, the latitude is giving us what? Let's get the center line. Okay, the latitude is giving us, okay, let's see what is the latitude. It says 50 degree north. That means you see P from 0 to move up to 50 degree north. You can see the angle 50 degree north. Okay, that is it, 50 degree north. Then let's put the circle there so that we can view it well. The latitude circle. So this is the circle of latitude. You can see it. Then on that point, let's get the small radius line, which is okay. So from there we can get our latitude, the small radius. So this is the small radius here. You can see it. That is it. So this is point P. You can view it very well. Point P. This is the small radius. Then this is the big radius to the equator. Then this is another big radius to the longitude. Take note of that. Okay, what next? We have located the first point 50 degree north. Then the second coordinate is 60 degree west. Then still on this point, another point move towards west. So the west is on this side, and that point of west is called what? Let me check. It's okay, that is point P. Sorry, it's still point P. Okay, so this place is not supposed to be point P. I'll just change the name. Okay, so P is actually on this place, 50 degree north. Then let me see. Then 60 degree west. So this place is supposed to be P. Let me change the name of this. Let me change it to, let me just say point D. Okay, so this is point P. This is point P. Okay, so actually point P from reference 0, it rises to this point D here, 50 degrees. Then it now moves 60 degrees towards the west side. So let me put our radius. Okay, then let's put the angle. Okay, okay, so 60 degree west. Okay, so this is the actual point of point P. You can see it now. Then let's put the latitude, sorry, the longitude line. So this is the line of longitude. You can see what we are talking about. Okay, let me hide the line, the point I don't need. I don't need point B. Let me just remove it from there. Let me remove this. Okay, so this is point P. Longitude 50 degree, latitude 60 degrees. You can see it towards west. Now this is our reference line, 50 degree north, 60 degree west. So we have settled that one, that is point P. So this is where the plane is now. Then the question moves on. It says it flew from this point P now, where it started from. So the plane started from point P, it flew to point Q. So this is point P. So the plane started from this point. So from this point, it flew to point Q. To which direction? Say due west. So it moved due west. And what is due west? That means it keeps going towards west. You can see it. You know, this is our reference line. East is on this side, west is on this side. So from here it moved due west, but the angle is not given. See, that is the next point, and that point is called point Q. Okay, let's see. Need to rename this to Q. I'm sorry. Okay, let's rename it to Q. Okay, so this is point Q. See, towards west. So it's somewhere on this side. You can see it now. Then let's put our line of longitude. This is your line of longitude. So you can get it very well now. But remember, this line is not given. See, this angle is not given. The angle of turning to this place was not given. So that's part of what they want us to calculate. That is what the question says we should calculate. The longitude of Q. You see, it's not known. But Q is towards west of P. You can see it. This is point P on the west. Then from point P, Q moves towards west, but we don't know the angle. So just leave it like that. We shall calculate it and we'll know the angle. Then what next? The question now says from Q now, also from point Q, the plane then flies due south from Q to another point called point Y. Then the plane now on this point let me rename this. So you move to another point Y. So this is point Y. It then flew due south. And due south, it can be somewhere here. It can be below the equator. So we don't really know the exact point. So we'll only find out this when we are through with our calculation. So this is the interpretation of this question. Take note of that. Start from P, flew west to Q. From Q, flew south to Y. So this is point Y. So this is the sketch in 3 view. I want you to view it very well and see it clearly. So with this now, we can go to our solution page, get your circle, don't forget to get the center, then you get your ruler, join your west and east line, then join your north and south line. Okay, then when you have done this, don't forget to label north, south, east and west. Then when you are through with this, then locate point P, start your solution. Then you label this is 50 degrees north, then 60-degree west is on this side. $60 on the west side. So this point is the point P. So that is the first point, 50-degree north, 60-degree west. So you have located it now. So this is what you draw in your solution paper that you will submit to the examiner. Then the plane now flew to point Q towards due west. So it keep going down to west. So somewhere here, Draw another one like this. Draw another one like this. Then you can label it also. You don't know the longitude, so just call it. Let's give it a symbol. Okay, let's call it beta. Let's call it beta. So beta degree. To beta degree west. We don't know it. It's what they want us to calculate, but make sure you label it in your sketch, and that is point Q. Okay, so this is point Q. Then the next thing from point Q now, it came down to another point. Okay, let's just say this is the point towards south. Let's say the point is somewhere here. That is point Y. Also label it angle alpha, since it's a latitude. But we can't say if it's north or south, because if this is a true angle, then it's north. But if this point Y, which is here, don't forget to label it, this is point Y. If this point Y is below the equator line is here, the alpha is going to be south. So until we are through with our calculation, that is when we can really decide, or we can know if it's north or south. So this is the sketch you have on your paper. With this sketch, we can get our solution. But let's start with PQ first. Let's start with PQ. Remember, we have found the distance PQ. So what we need is this angle, this beta degree west, which is the longitude of Q. So how do we get that? Remember, we need to know the angle between Q and P. So since P is already at 60 degrees west and beta is very far, is far west, so that means beta is bigger than Q. So the angle between Q and P is going to be beta minus 60 degrees. Just take note, from 0 to P is 60, then from 0 to Q, you don't know it, which is beta, and that is the longitude of Q. If you do that, you will get your answer. So let's go and do that. So what we need to do here is you write angle between P and Q. Okay, that is A is what we are calculating now. So you write now angle between P and Q is, this angle will now be, remember we label it as beta, so it will be beta, that is beta minus 60, beta minus 60 degrees. We can put it in bracket so that, okay, let's put it here. Let me put it in bracket. Okay, let me just leave it like that, or let me start again, which is beta minus 60. Okay, so that is the angle. Take note of that. Angle between P and Q. Okay, so now let's go to our solution now. So distance PQ, we have calculated it as 1800. So PQ will be equals to theta over 360. Theta over 360. Remember, that is the same formula we use. Theta over 360 times 2 pi r. You know why we are using small letter r? Because P and Q, let's see, P and Q, they are standing on the small circle. That's it. So you use small letter r. So we need to find small letter r. We need to calculate the radius. So how do you get small letter r? So small letter r is equals to capital R cos alpha. And remember, the alpha is going to be the latitude, which is 50 degrees, latitude on which they are standing. Both of P and Q, they are standing on latitude 50 degrees. So P and Q, you can see it. PQ, they are standing on latitude 50 degrees. You can see it. So this is the latitude we are going to use. So R cos 50 degrees. And R, let me just put it there. R is 6,400 times that. Then your answer will now be, you can use your calculator. Let me use my calculator and do it fast. So 6,400 times cos 50 is going to be equals to 411, that's 4,113, 4,113 4,113.8407 8407 kilometer. Take note, always put your units, very important. So this is the small radius. Then we substitute our values and we get our theta will now be equals to this now. Don't forget, this will now be our theta. So distance PQ 1800 is equal to, open your bracket, put your beta minus 60. Okay, let's adjust it. So beta minus 60 divided by 360 times 2 times pi is 3.142. Always follow what they say you should use. Take note, 3.142 times R, which we have calculated, 4113.8407. Alright, then the next thing is, let's solve this one. If we solve this, let me do it here. We are going to have 2 times 3.142 times 413.8407. Let's put it in decimal form. So in decimal, you are going to have that, which is 1,800 is equals to beta minus 16 divided by 360 times this value here, which is 25,851.375. So use your calculator and check the solution. You'll get it well. Let's move down a little. Okay. Just use your calculator and times, we get this. Then the next thing is to cross multiply 360 times 1,800 divided by 25,851. So let's do it and get our beta. So beta minus 60 will now be equals to 1,800 times 360 divided by 25,851.375. So which is beta minus 60 now be equals to, let's simplify this with our calculator, 1,800 times 360 divided by 25,851.375. We are getting 25. Get 25.066. So finally, collection of like terms. When you collect your like terms, let's remove this out in bracket. When you collect like terms, minus 60 will become plus. It will now be beta. Now be beta is equals to 25.066 plus 60. So beta is equals to, will now be equals to 25.066 plus 60, which will now give us 85.066. Then 85.066 is the longitude. That is the longitude of a point Q, and it's in degree. So degree, and it's towards west, degree west. So you take note of that. Then the question says we should leave our answer. Let's see. So we should leave our answers to 3 significant figures. So since it's 3 significant figures, so let's approximate it. This is 1, 2, 3. So we add 1 to it. So finally, beta will now be 85.1 degrees. 85.1 degree west. So this is beta. So take note of this. We don't need this. Let me remove this. So beta is 85.1 degree west. That is this latitude of y. Remember, let's go to the diagram. Remember, y and q, they are standing on the same longitude. So we have found the longitude to be 85.1 now. So since we know the longitude, then the next thing is, how do we get this angle now, this latitude? So we need to know the angle between q and y. So since we don't know the angle, what we need to do now is, let's just take the angle to be theta first. Let's take the angle to be theta. So if we get theta, then from there we can do our substitution to know what to do now. But remember, q, the longitude of q is 50 degrees. You can see, but we don't know the longitude of y. So let's just find theta. Whatever we get as theta, then we'll see if it's greater than 50, we are going to subtract. That will give us the latitude of y. Then if it's less than 50, we are going to add. But when we do finish that, you understand it. Okay, now the B part is, okay, the B part, latitude of y. So y is standing with q. Both of them are on the same latitude, on the same line, and they are on the great circle. So we are using capital R. Okay, so now let's go straight. The distance is already known, 500. So distance QY, which is QY is equals to theta over 360. Theta over 360 times 2 pi. Use capital letter R because they are standing on the great circle. Okay, so next, QY is 500. 500 is equals to, let's leave the theta like that. When we are through, we shall check. So theta over 360 times 2 times 3.142 times the big radius is giving us 6,400. Then without wasting time, let's cross multiply with this and divide by this value. If we do it fast, we'll have our theta. Theta will now be equals to 500 times 360 and divide the result by 2 times 3.142 times 6,400. Okay, then theta will now be what now? Let's do it fast with our calculator. Let's do it somewhere here to get the answer. 500 times 360 divided by 2 times 3.142 times 6,400. So it's giving us 4, which is 4.476. So this is the angle that is given. So the angle between Q and Y is 4 degrees. So if the angle is 4 degrees, you can see that it's very close. Both of them are very close to each other. They are very close to each other. So all we need to do now is this. Let's look at the diagram. So Q and Y, you can see the angle between them, I got a very small answer, which is 4 point something. So that means Y is even close. Y is somewhere here, not this place where I placed it. Y is somewhere here. That means from this reference to Y to Q is 50. Then from reference to Y, we don't know it, but we know the angle between them. So if we do 50 minus that 4 point, we'll get alpha. So all we need to do now is our final answer will now be alpha equals to 50 minus 4.476, and this will give us, if I do it here, let me check, 50 minus 4.476 is going to be 45.524. 45.524, and this is going to be in degree, that is degree knots. So take note of that. Then finally, don't need this, let's take this out. So finally now alpha is equal to the question says we should approximate to 3 significant figures, which is 1, 2, 3, that is 45.5 degree knot. So this is our final answer. Alpha 45.5 degree knot, that is latitude of point Y. Let me give small space. Okay, so this is the final answer for this question. Yeah, 2003 number 11 theory. Longitude of Q and latitude of Y. So the longitude of Q is 85.5 degree west, then the latitude of Y is 45.5 degree north. So go through the step again, follow the equation very well, follow the information, and you see that it's not difficult. So thank you for listening.